In section 6.1, we want to go back and talk about inverse trig functions, which we've already done a little bit, but we were doing it in one specific situation, solving right triangles for the most part. And so we didn't go into as much depth as is needed. So we did it in a very specific instance. We used the calculator, which gave us the answer we needed. So if you recall from college algebra, for a function to have an inverse function, its graph had to pass the horizontal line test. For example, if you look at the sine graph, and you don't need to draw these down. We've already done this before. I've just put it up here so I can use it to motivate where we're headed. Notice the sine graph. Sine of 0 is 0. Sine of 0 is 0, and sine of pi is 0. Right? Sine of 0 is 0. Sine of pi is 0. Well, remember when we do the inverse trig function, sine of an angle is a number. So sine inverse of the number should be the angle. The problem here is, well, sine of 0 is 0, right? 0 is the angle. Sine of pi is 0, so if I take sine inverse of that number, what angle should I spit out? 0 or pi? Or 2 pi, or 4 pi, or, for that matter, or 3 pi, right? There are a lot of angles whose sine is 0, so when you take sine inverse of 0, what angle should you spit out? Remember, we want the inverse trig function to be a function, so it should only spit out one answer. So we did some hand waving before. We sort of ignored this problem, right? You recall from college algebra, for a graph to have an inverse function, a function to have an inverse function, its graph has to pass the horizontal line test. Meaning if you draw a horizontal line, it only can intersect the graph in one place. Well, I've grabbed all 6 of our basic trig functions, sine, cosine, tangent, cotangent, cosecant, secant. If you draw a horizontal line, you hit every single one of these graphs in more than one place. Well, here you don't, but there's no graph at all, right? It has to pass the horizontal line test everywhere, right? That crosses a graph infinite number of times, infinite, 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 right? If I draw it down here, you're going to cross the down cups in 2 places every single time, okay? So the original graphs here on their original domains do not have inverses. So what we do is we restrict the domain, okay? Now what we want to do is take a piece of the graph so that will pass a horizontal line test, and it has every possible value of the range. So for example, sine, I want a piece of the graph that it contains every value from -1 to 1 for y values and will pass the horizontal line test. Now if you just take one period, for example from 0 to 2 pi, I get every value in the range from -1 to 1, but notice that still won't pass the horizontal line test. So what we do for that is we go from minus pi over 2 to pi over 2. Just take that piece that I'm doing in green here, if you could see it. Okay? So I'm just going to take this piece of the sine graph from minus pi over 2 to pi over 2. Notice I've got every value in the range from -1 to 1, and my green graph here does pass the horizontal line test. Now we want to do that with all 6. Now, what about cosine? Well, why don't we try to take the same thing, minus pi over 2 to pi over 2, which would be from here to here. But notice, right, we don't have every value in the range from -1 to 1, and that piece wouldn't pass the horizontal line test. So for cosine, we have to choose a different piece of the graph, and here we go from 0, x equals 0, to x equals pi, and we take that piece. Right. We could have taken the piece from minus 2 pi to pi if we wanted to, but we're trying to stick to things close to 0. Notice I have every value in the range, -1 to 1, and the green piece that I've drawn here does pass horizontal line test. Now what about tangent? I think it's kind of obvious what you want to pick for tangent, right? From minus pi over 2 to pi over 2. Of course, not pi over 2, because those are asymptotes, but, okay? Notice tangent, the range was all real numbers, so I have all real numbers, and this piece will pass horizontal line test, so I'm not taking those. Now what about cotangent? It would make sense to pick one of the branches again. Here we go 0 to pi. Okay, so not that. Now what about cosecant? Goodness. So you need all the values from 1 and up, all the values from -1 down, and so you can't take our whole cup, because that wouldn't pass horizontal line test. So for cosecant, we take half of the up cup here and half of the down cup here. Notice the graph I've drawn in green will pass a horizontal line test, and I have all the values from 1 up and -1 down. Again, you can't take the whole cup because then it wouldn't pass horizontal line test. And lastly, for secant, again, we need half of the up cup and half of the down cup. So we take the right-hand piece of that up cup and the down piece, the left-hand piece of that cup. And notice you have all the values from 1 and up, minus 1 down, the entire range, and my green graph here will pass horizontal line test. Now, I know that looks like, oh my gosh, how are we ever going to remember that? But I want you to notice there's some commonalities here. Notice that this sign is going from minus pi over 2 to pi over 2. So is tangent, but it's not including the endpoints. And so is cosecant, but cosecant, notice we're not including 0, right? There's no graph on 0. Okay? But you don't have to worry about the problem places. You really don't. If you can just remember minus pi over 2 to pi over 2 for those 3, you're good. Now what about the other 3? 0 to pi, not including 0 and pi. 0 to pi. 0 to pi, not including pi over 2. Okay? So again, what I try to argue is how do we restrict the domain to define inverse trig functions? So just to summarize pictorially, this is what I do. Because there's only 2 regions you have to think about. Right? So I think of this. So from 0 to pi over 2, and then 0 to minus pi over 2. So minus pi over 2 to pi over 2, that's sine inverse, cosecant inverse, and tan inverse. So when you take sine inverse, cosecant inverse, or tan inverse, you get an answer from 0 to pi over 2 or minus pi over 2 to 0. Typically, I will say first and fourth quadrants, but be careful. When I say fourth quadrant, you can't go all the way around, okay? It's not, 300 degrees, it's negative, 60 degrees, okay? So you go 0 to pi and 0 down to minus pi, okay? Based upon what we did before. Those 3 were from minus pi over 2 to pi over 2. So you rotate up to pi over 2 and down to minus pi over 2. And then the other 3 were 0 to pi. So cosine inverse, secant inverse, and cotan inverse. So if you could just remember, these 3 give you answers here, the other 3 go from 0 to pi. Notice you are never in the third quadrant. So when you take cosine inverse of a number, you never get an angle in the third quadrant. Any trig function, any inverse trig function, you never get an answer in the third quadrant. This is the only new thing in this section. Okay, this is the only new thing about where these answers. And so I wrote it all down there, in the notes there. Yikes! But let me just summarize with the sign what I did in the notes there. So when we took sine of an angle, we got a number, right? And what did you know about that number? When we took sine of an angle, that number, if I call it y, was always between minus 1 and 1, right? So if you take sine inverse of the number giving you the angle, the number here is between minus 1 and 1. Because if you take sine inverse of a 2.7, you're going to get an error message, right? And now this is the new thing. What angle do you get? You get an angle from minus pi over 2 to pi over 2. Okay? So and you don't even really have to remember that, because if you take sine inverse of 3, it's going to give you an error message, right? Okay? So that's the way all these work. So when you take cosine inverse of a number, remember that number is going to be between plus or minus 1. And where's that angle going to be? From 0 to pi. Right? That's the only thing you have to remember is this. Okay, let's do some examples. It says find each exactly in radians. The homework instructions say find the real number. When they say find the real number and it's an angle, that means radians, okay? So if you're ever trying to find an angle and the instructions say it's a real number, that means it's a radians. That's why we don't always write the RAD for the units, because if you leave them off, we know it's radians, and also because you can also think of a radian as a real number. Okay, so it says find sine inverse of square root of 2 over 2. Okay, so find the exact value in radians. You could do all of these in degrees as well. So it'd be minus pi over 2 to pi over 2, it'd be minus 90 to 90 degrees. Okay, so here's how I approach all these problems. Okay, first of all, what kind of thing is this? Right, this is a number. You take sine inverse of a number and it spits out an angle. I'm just going to call it theta, just to call it something. Right? It's not what this looks like. You're taking sine inverse of something, so the something's a number. Sine inverse of a number is an angle. Right? Let's write the 2 facts that we know. Okay, this is what I do on every single one of these problems. Write the two facts. Sine inverse of a number is an angle. So sine of the angle is the number. And the new thing is, in which quadrant is theta? Okay, if you take sine inverse of a number and it spits out an angle, that angle is either in the first or the fourth. Now, which quadrant is it? Is it first or fourth? Well, sine is positive, right? Where sine is positive, you're in the first quadrant, and notice in the fourth, well, all three of these trig functions, well, sine, cosine, not the inverse, sine, cosecant, tangent, are positive in the first and negative in the fourth. And cosine of x, secant of x, and cotan x, not the inverse functions, are positive in the first and negative in the third. So we chose these where they're, positive and negative, positive and negative. So if you're taking sine inverse of a positive number, you know you're in the first. If this had been a negative number, I would have been in the fourth. So very easy. Now, we did problems like this in chapter 2, long time ago, right? You know one trig function value and you're told what quadrant it's in. You can draw a picture of that. Let's draw a picture. So this is the only new thing, going from this statement to the two facts. We've done these before when you have the two facts. Okay, theta's in the first quadrant. I know that's the correct rotation. This is not the scale though. Sine is root 2 over 2. Well, sine is y over r, or opposite over hypotenuse. Okay, now we're trying to find the angle theta here. We're trying to find the angle. Now, you may not recognize this, but I know this is one of our special triangles. A clue is that it said find the exact value, so it's either going to be a special triangle or a quadrantal. But if you don't recognize it, if you found the other side, use Pythagorean theorem, x squared plus root 2 squared is 2 squared, you'll get that the other side is root 2. Okay, so if you need to do that, you can. Use Pythagorean theorem to get the other side. Hopefully now you recognize it's one of our special triangles. It's not the numbers I always use, but it's the ratios. Notice this side and this side are equal, which means this is your 45-degree angle. But again, they wanted the answer in radians, and so we know that's pi over 4. It's 45 degrees. Okay, so once you have this, write the two facts, draw your picture, and use stuff we've done before. That's the only new thing is this, what quadrant things are in. Okay, let's do the next one. It says tan inverse of -1. Okay. Tan inverse of -1. Again, I'm taking tan inverse of this, so I know that's a number. Tan inverse of a number, that's a number, is going to equal an angle. Again, I'll call it theta. Always do this analysis, right? You take tangent of an angle to get a number, tan inverse of a number gives you the angle. Well, let's write the two facts. If tan inverse of the number is the angle, tan of the angle is the number. So that's our first fact. And now the other question is, in which quadrant is theta? Well, if you take tan inverse of a number, you're either in the first or the fourth. But notice tangent turns out to be negative here, so you're in the fourth. Again, that's the new thing. What quadrant are we in? Okay, so if you take tan inverse of a positive number, your answer is in the first. Tan inverse of a negative number, you're in the fourth. Let's draw a picture. Now, when I say fourth quadrant, you're not rotating all the way around, you're just rotating down. So, again, this is not the scale. The key is I know I'm in the fourth quadrant. And I need to put in my sides, think of that as -1/1. And tan is what side over what side? It's opposite over adjacent, or y over x. So y and x, it's 1/1. I always put the numbers in, then worry about the plus or minus, and the minus is on the opposite side. Right? So tangent is that over there. Well, I don't really need the other side. Again, the two legs have the same length, which means this is my special triangle, my 45, 45, 90. The reference angle is 45 degrees, or pi over 4. Now be careful. What is the actual angle theta? It has a negative rotation, so it's negative pi over 4. Okay? Okay, the next one says, find arc cosecant of -2 over √3. Now, I didn't mention this before, but maybe we did when we did it before. Arc cosecant is the same thing as cosecant inverse. Okay, this. So these are saying the same thing. Cosecant inverse and arc cosecant are exactly the same thing, so just be aware of that. So I may use them interchangeably, and the book is too, so. Okay, so, again, arc cosecant, cosecant inverse. of a number is an angle, right? That's a number because I'm taking arc cosecant of it. That's going to be an angle, which again I will call theta. Let's write our two facts. Arc cosecant of a number is an angle, so cosecant of the angle is the number. And then the other fact is in which quadrant is the angle theta? Well, I'm taking arc cosecant of a negative number. Arc cosecant gives me an answer in the first or the fourth. Cosecant of an angle is positive in the first, so this must be in the fourth. Arc cosecant of a negative numbers in the fourth quadrant. That's right. Okay, let's draw a picture. Okay, theta's in the fourth quadrant, and again, fourth quadrant, you don't go all the way around in a positive direction, it's negative. So my answer here is going to be a negative angle. And cosecant, ignore the minus sign, 2 over root 3, well, cosecant was hypotenuse over opposite, or y over, r over y, so that's that. And the negative obviously goes on the root 3. Well, these are the numbers in one of our special triangles, right? So I know the other side's at 1. And then what's my angle here? Well, this is my 30, 60, 90 triangle. And notice the 30 degrees is opposite the 1. That's the 60 degrees. But again, they want the answer in radians. So the reference angle is pi over 3, my 60 degrees. But again, think about what angle it is. You're going in a negative direction, so it's negative pi over 3. Don't just give the answer as the reference angle. You have to put the rotation in there as well. Okay, then the last example on this page says arc cosine of negative 1. Again, arc cosine just means cosine inverse. You take arc cosine of a number and it spits out an angle, which I, again, will call theta. Okay. Now, let's just go blindly forward with the way I've been doing it. Let's write our two facts. Arc cosine of a number is an angle. Cosine of the angle is the number. And if you go from what I have here, right, cosine inverse gives you the answer in the first or the second. This you're taking a cosine of theta turns out to be negative, so you're not in the first. So if you just go with what I've been doing, you would say theta is in the second quadrant. Right? Arc cosine of a negative number puts you in the second quadrant. Right? Now let's draw a picture. Now don't draw this, just watch me because I'm going to erase it. Right? If I draw theta in the second quadrant like this, right? Draw theta in the second quadrant. That is the correct rotation, right? They go this way for these three. Okay, so this is my theta. Well, let me put a 1 over that to give me two numbers to make sides of the triangle. Well, what's cosine? Cosine is adjacent over hypotenuse, or x over r. Well, so there's x and there's r, and there's a negative there. Now, do you see the problem? I've drawn a right triangle where the leg and the hypotenuse have the same length. That can't be. So does that mean the answer is undefined? Right? Well, no. That means I'm not drawing the correct picture. Remember, we always wound up with two different pictures. Triangle pictures, and what was the other one? Quadrantal pictures. This picture doesn't make sense in this circumstance, right? So you see the problem. Well, that's not exactly right. What I've written here is fine, but the picture doesn't make any sense. That's the dead giveaway that it's not a triangle picture. That should tell you that we're doing a quadrantal, so it's either here or here. So technically, that is not a true statement, right? I'm on an axis. To be in the second quadrant, you have to be here, right? Not on an axis. So technically, that's not right, but that helps me, right? I know it's not here, right? Cosine inverse goes from here to here. I know it's not here. It's either here or here. So you may, if you draw a triangle picture that doesn't make sense, that means it's either you made a mistake in some of your calculations, or it's not a triangle picture, it's a quadrantal picture. So remember, this is the point 0, 1. Pick the point 1 unit away. And which number gives you cosine? Remember, cosine is the first number, so it's here. Now, what angle is this? From here to here. Again, that's 180 degrees, but they want all the answers in radians. That's pi radians. So there's the answer. All right, so this one's a little tricky because it turns out to be quadrantal. Okay. Certainly, if you ever get, arc cosine of 0, sine inverse of 0, tan inverse of 0, that's a dead giveaway. It's going to be a quadrantal. Right? Because you can't draw a triangle picture with a side of 0. So if you're ever taking an inverse straight function of 0, you know it's a quadrantal to start with. So that'll save you a little bit of time. Okay, the next example say, use the calculator to find each of the following. So we've done some of these before. The first one you ought to be able to do, it says y is sine inverse of 0.1234 y is in radians. They want the answer in radians. So go ahead and punch that in while I write these other ones down. Okay, so you're taking sine inverse, so I don't have to write the facts here because I'm just using the calculator. I'm not trying to find exact value. Sine inverse of the number is an angle, so I want the angle y in radians. So you need to set your mode to radian mode. So because it's spitting out an angle, so if your calculator's in radian mode, it'll spit it out in radians for you. So sine inverse of 0.1234 turns out to be 0.1237 to 4 places. So sine inverse of that number is that angle. Sine of that angle would be that number. Okay, we did this a long time ago. When we did it in degrees though. We've never done it in radians. Okay, what about the next one? Y is arc sine of 1.34. Well, y is in degrees. Remember, arc sine just means sine inverse. So if you want your answer in degrees, you have to change to degree mode. And you type down sine inverse of 1.34. Again, you should be playing along with me. Don't just watch me. And I got a domain error. Now, does that mean I typed something in wrong? Or what does that mean? Domain errors means I'm asking the calculator to compute something it doesn't know how to compute. Now, think about why this is. If I did write the two facts here, what would this be? Arc sine of a number is an angle. So sine of the angle is the number. And you see that's a problem, because sine of an angle was always between plus or minus 1 inclusive. So this doesn't make any sense. You're asking the calculator to find something it doesn't know how to find. So there's no solution here. Undefined, no solution, or something like that. Okay. I put one in here like this so you could see the error message on the calculator. Okay, the next one says cosecant inverse of 1.713. Now, if you look very closely on the calculator, you're not going to see a cosecant button or a cosecant inverse button. So what do we want to do? We want to change this to a sine problem, which is the reciprocal. Remember, cosecant inverse does not mean sine. 1 over cosecant is sine, okay? This means inverse function or composition. It's not the same thing. Right? So let's first change this to a cosecant statement, okay? Just like our two facts. Cosecant inverse of numbers and angles, so cosecant of the angle is the number, okay? No problem. Now let's change it to a sine statement. Cosecant and sine are reciprocal. So how do you get sine from cosecant? It's the reciprocal 1 over. Okay? So I changed my cosecant inverse to a cosecant statement and the cosecant statement to a sine statement. Now let's go back to sine inverse. Sine of an angle is a number, so the angle is sine inverse of the number. And I encourage you to write out the steps. I always have students that try to go from here to the answer and they don't remember exactly what's the reciprocal and then they get it wrong. And they just write down the wrong answer. I can't give anything for it. Okay, so now we wanted the answer to be in degrees here. I am in degree mode. So sine inverse of 1 over 1.713. So y here is 35.716 degrees. Okay? Okay, pause the video and see if you can do the last one on your own, and then turn it back on, and then I'll work it out, and we'll see if we get the same thing. So go ahead and work that one out. And notice the answer here is supposed to be in radians. Okay, so let me work this one out. So it works the same way here. So first let me change it. I don't have a secant inverse button, so let me change it to a secant problem. Secant y is 1.41. Let me change it to a cosine problem. Cosine is 1 over 1.41. And so cosine of an angle is a number, so the angle is cosine inverse of the number. Again, let me put my calculator in radian mode, and then take cosine inverse of 1 over 1.41, and I get about 0.7824 radians. Notice these answers make sense, right? You take cosecant inverse of a positive number, where does that put you? First quadrant. first quadrant. If you take secant inverse of a positive number, where does that put you? First quadrant. 0.78 radians. Remember, 1 radian is about 57 degrees, so 0.78 radians is in the first quadrant. Okay. Okay, let me erase these. Hopefully by now you have an idea where these things live. Now let's get a little more complicated. It says, find the exact value of the following. If the answer is an angle, use radians. Okay, it says find secant of sine inverse of 3/5. Now let's think about what's going on here. What type of thing is 3/5? Is it an angle or is it a number? And it's not based on what it looks like, it's based on this. You take sine inverse of a number, which gives you an angle. And then secant of an angle gives you a number. So my final answer here is a number, not an angle. Okay? Let me not worry about the secant for now. Let's just focus on this. Let me just call this angle. So sine inverse of 3/5, I'm going to call theta because it's an angle. Let's write the two facts. Notice there's only one extra step in this problem. I'm ignoring the secant, and I want to draw a picture of my angle theta here. So sine inverse of a number is an angle, so sine of the angle is the number. And where is that angle theta? Remember, sine inverse gives you an answer in the first or the fourth. Since 3/5 is positive, we know we're in the first quadrant. Right? So there's nothing new here. Right? This is exactly what we did before. Let's draw a picture of angle theta. I know theta is in the first quadrant. I know that's the correct rotation. Sine of theta is 3/5, so that's opposite over hypotenuse, or y over r. And we can figure out the other number with Pythagorean theorem, but this is a triangle we did on the very first day, and I told you it's going to pop up a lot in this course, so just memorize it. Remember 3, 4, 5. When 5 is on the hypotenuse and 3, that's a 4. If you didn't remember that, you could use Pythagorean theorem. So this is a picture of angle theta. I don't know what theta is. I don't know if theta is 20 degrees or 32.8. I have no idea what theta is. But notice I have a picture of angle theta with the 3 sides. Well, let's go back to the original question. Right? This theta is this angle right here. This whole thing is angle theta. And it says find secant of that theta. Right? My angle here is theta. All it's asking for is what's secant of theta? Well, we have a picture. Right? What's the secant of this angle? Right? Secant is hypotenuse over adjacent, or r over x. So it's 5/4. So notice I never did find the value of theta, but I don't need it. I used the two sides, the two numbers here to get two sides of the triangle, use Pythagorean theorem for the third, and then just find the secant of that angle, and there you go. Okay, that's the first one. The second one, B, says sine of sine inverse of a half. Sine of sine inverse of a half. Okay. So let me investigate what kind of answer we have. Is this an angle or a number? You're taking sine inverse of it, so that's a number. Sine inverse of that is an angle, and sine of an angle is a number. So it's like the one we just did. Okay, let me call this angle theta again. So I'm calling sine inverse of a half theta. I'm ignoring the sign out front for now. Well, let's write our two facts. Sine inverse of a number is an angle. Sine of the angle is the number. And in which quadrant is theta? Well, you're taking sine inverse of a positive number. Oops, not equal. You're in the first quadrant. When you take any inverse trig function of a positive number, you're going to be in the first quadrant. So there's my two facts. Let's draw a picture. Okay. So theta's in the first quadrant. Here's theta. And sine is a half. Sine is opposite over hypotenuse, or y over r. You know this is one of our special triangles, right? 1, 2. I know that's square root of 3. But if it wasn't a special triangle, use Pythagorean theorem to find the other side. Okay. Now let's just look at my picture. This is angle theta. This whole thing is angle theta. This says find sine of theta. Well, what's the sine? Opposite over hypotenuse, or y over r, that's a half. Now, we did a lot of work to get to the final answer. If you think about what this is saying, right? Sine inverse of a half is an angle whose sine is a half, right? That's what this says, right? Sine inverse of a half is theta. That means sine of theta is 1/2. So you're saying, what's the sine of an angle whose sine is 1/2? Well, it's obviously 1/2. So you really didn't have to work this one out. Now, I'm doing this because I'm going to do another one, but I'm going to reverse the order. I'm cautioning you about just saying sine and sine inverse cancel each other out, and the answer's a half. Let's look at sine inverse of sine of pi. So I still have a sine inverse and a sine, just like in the last problem, but they're not in the same order, they're backwards. Right? This is why I'm cautioning you about just saying they cancel each other out somehow. Okay, so is pi a number or an angle? You're taking sine of it, that's an angle. Sine of the angle is a number, and sine inverse of the number is an angle. So here the answer is an angle, not a number. Well, let's just compute, right? Sine of pi, right? That's a number. We can compute that. Pi is a quadrantal angle here, right? So that's minus 1, 0. I'm picking a point 1 unit away. I'm using the unit circle. Well, what's sine of pi? Sine's the second. Remember, cosine's first, sine is second. So sine of pi is 0. So this is the same thing as what's sine inverse of 0, right? This turns out to be 0. Sine of pi is 0. Okay, now let's work this out, right? Sine inverse of a number is an angle. Let me call that theta. And let me write my two facts. Well, we have to be careful. Sine inverse of a number is an angle. So sine of the angle is the number, just 0. Sine inverse of a number is an angle. Sine of the angle is a number. Now, it doesn't make sense to me. Sine is 0. It's not a triangle. This is clearly quadrantal, right? Theta is going to be a quadrantal angle. Because you can't draw a triangle with the side of 0. I mentioned that earlier. Well, let's draw a picture. Well, where does sine live? Sine is here and here, so we're either going to be here, or here, right? Sine inverse lives here. That's the point 0, 1. That's the point 1, 0. That's the point 0, minus 1. Again, I'm using quadrantals and unit circle. Where is sine 0? Remember, sine's the second number. It's here. So that's the angle. I notice that's 0 radians. 0. Notice here, sine inverse and sine, you can't just drop off and say the answer is pi, right? So you have to be careful. It depends upon the order whether you can just drop it or not. So I usually just work it out just to make sure. The reason why you can't is, if you take sine inverse of a number, it spits out an angle. The angle has to be from minus pi over 2 to pi over 2. The answer can't be pi, because pi is outside the range of the inverse sine function. Okay, that's why you can't. If this had been a 0 here, if this angle here were from minus pi over 2 to pi over 2, you know you could just drop those because you're going to get the same angle that's there. Pi is outside of that range for the inverse sine function, so you know that can't be the answer. Okay, let's do one more of this type. It says find tan inverse of sine of pi over 2. Okay? So you're taking sine of this, so that's an angle. You take sine of an angle, and that spits out a number. Tan inverse of a number is an angle. So again, I always do this sort of analysis so I know what I'm looking for. I'm looking for an angle here in radians. Well, we can figure out sine of pi over 2. Let's just go ahead and do that. There's pi over 2. It's a quadrantal. Pick the point 1 unit away, 0, 1. And sine's the second number, right? Cosine, sine. Sine's the second number. So sine of pi over 2 is 1. So what I'm really looking for is tan inverse of 1. That's what I'm looking for. Again, I know the answer is an angle. Let me call it theta. Now we're back to what we did before. Let's write the two facts. Tan inverse of a number is an angle. So tan of the angle is a number. And where is that angle? You're taking tan is positive, so you're in the first part. If this had been a negative number, your tan inverse would be in the fourth. Well, let's draw a picture. Right? We're in the first quadrant. There's the correct rotation. Tangent is 1, so let me think of that as 1 over 1. That's opposite over adjacent, or y over x. I don't even need the other side. You know what square root of 2, but I mean, you already know what the angle is. The two legs are equal. The two legs of the right triangle have the same length, which means this is my 45-degree angle, which is pi over 4 radians, and that's the answer, pi over 4. So that was not that hard to do, right? I mean, the last two, the quantity here, you could compute sine of pi over 2, or the last one was sine of pi. You can compute that. That's no problem. Okay, our last problem here, last example, takes a little bit more work. It says find the exact value of tan of arc sine 3/5 plus arc cosine of minus 3/5. Wow. Wow, that's a lot going on. Well, let's investigate what we have here. 3/5 and minus 3/5 are what kind of things? Are they angles or are they numbers? Well, they're both numbers because you're taking arc sine and arc cosine. So that's a number. That's a number. When you take arc sine of a number, you get an angle. Arc cosine of a number, you get an angle. An angle plus an angle is another angle, and then tan of an angle is a number. So our final answer here is going to be a number. Okay. Now, just to save myself some writing, right? Let me call this angle something and call that angle something. Let me call the first angle here A, and I'm going to call the second angle here B. Let's see if we can draw pictures of those. So I'm saying arc sine of 3/5 is angle A, and here I'm saying arc cosine of minus 3/5 is angle B. What can we draw? Let's write the two facts for each of those. Arc sine of a number is an angle, so sine of the angle is the number. And where's angle A? You're taking arc sine of a positive number, that's A is in the first quadrant. Arc cosine of minus 3/5, well that means is B, that means cosine of B is minus 3/5. And now where is angle B? Do you know what quadrant B is going to be in? Remember, arc cosine gives you answers from 0 to pi, first and second quadrant. Since this a number is negative, B is in the second quadrant. Right? Well, can we draw a picture of each of those? Right? A is in, well, let me do this better. A is in the first quadrant. Here's angle A. Sine is 3/5, that's opposite over hypotenuse, y over r. And we did this earlier, the other side's 4, isn't it? Now here, B is in the second quadrant. There's B. Remember, B is not the reference angle, B is the angle in standard position. Cosine is minus 3/5, that's adjacent over hypotenuse, or x over r. Again, the other side's 4. Again, don't forget to check for negatives, but my 4 here and my 4 here are both positive. Okay, so I know what A looks like, I know what B looks like, but what are we interested in? We're interested in angle A plus angle B. I don't know how big A is, I don't know how big B is. So I can't just add those, it's just A plus B. But we don't need to. Now, why did I call these A and B? I want you to realize I'm trying to find tangent of A plus B. I wrote A and B on purpose to remind you. We had an identity in chapter 5 that addressed this, right? So I'm going to erase this and work on that part. I just really need the pictures, right? Let me just leave the pictures. That's really all we need. So there's a picture of A, there's a picture of B. I'm trying to find tangent of A plus B, aren't I? Notice I want to know about the angle A plus B. I don't know A plus B, but I know A and I know B. That's a dead giveaway. To go back to section, I believe it was 5.4, and do the sum and difference formula for tangent. Remember the formula was tan of A plus tan of B over 1 minus tangent of A, tangent of B. Right, that was our formula. And what does this do for us here? I'm trying to find tan of A plus B. I don't have a picture for A plus B. But I have a picture for A and I have a picture for B, so I can plug them in here. So I transferred it from a question about angle A plus B to a question about angles A and B. And now we can just plug in, can't we? Because tangent of A and tangent of B we can get from our pictures. Tangent of A is 3/4. That's 3/4 plus. Tangent of B is minus 4/3 over 1 minus tangent of A was 3/4, tangent of B is minus 4/3. Right? So tangent of A here and here was 3/4, tangent of B was minus 4/3. So now it's just a matter of simplifying. Okay, let me simplify that denominator. 3/4 minus 4/3 over 1. Now, it's a negative 3/4 times a negative 4/3, so a negative times a negative is a positive. And 3/4 times 4/3 is 12/12, which is 1. So that simplifies it a little bit. Now, there are a couple of things you can do here. But just to practice something I mentioned a while back, when you have fractions and fractions, remember one way I told you to do, think of these as, everything over a denominator. So I have a 4, a 3, a 1, and a 1 on the denominators. The least common multiple of 4, 3, 1, and 1 is 12. So So if I multiply this by 12 over 12, you can wipe out the fractions in one fell swoop, right? What's 3/4 of 12? Think of that as 12 over 1. 4 goes into 12 3 times 3 is 9. Think of this as 12 over 1, right? 3 goes into 12, 4 times 4 is 16. And the denominator, I have 2 times 12 is 24. Notice you get minus 7 over 24. Or you could get a common denominator, subtract the fractions, and then multiply by half. I mean, that's kind of wrong. I could have done this 12 over 12 step right here if I wanted to. Because you would have got 9 minus 16. You would have got a 12 here, and the 4 and the 3 would cancel with the 12. You get a 12 plus a 12. And notice you still get your 24. So that's tangent of A plus B on that. So the key here was recognizing, right, they want to know the tangent of a sum, but you didn't know anything about the sum. You knew about A, you knew about B, so it's a clue to use the sum formula for tangent that we covered a few sections back. So that's how you do that one.